Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify reactive functional groups. The starting material is 3-oxocyclohexane, 1-carboxylic acid, a cyclohexanone bearing a carboxylic acid group at C1 on a wedge bond. NaBH4 is a mild reducing agent that selectively reduces ketones and aldehydes, but does not reduce carboxylic acids under normal conditions. Step 2. Determine which group is reduced. NaBH4 reduces the ketone C is equal to O at C3 to a secondary alcohol, ChO at C3. The CO2H group at C1 remains intact. Step 3. Determine stereochemistry of the new O. The starting material has a fixed stereocenter at C1, CO2H on wedge. NaBH4 delivers hydride from the less hindered, equatorial axial phase. The CO2H group at C1 is on the wedge, axial in one conformer. Hydride delivery to the ketone at C3 preferentially occurs from the axial direction. Equatorial attack is preferred in cyclohexanone systems, giving the more stable equatorial alcohol, or from the phase opposite to the existing substituent, anti-addition relative to the CO2H. The major product has the newly formed O at C3 on the dash, opposite phase to CO2H, giving a trans relationship between O and CO2H. This corresponds to option A shown on dashes at C3, CO2H on wedge at C1. Step 4. Eliminate other options. Option B places O on a wedge, same phase as CO2H is equal to CIS product, minor product. Option C shows the ketone unreduced and CO2H reduced to CH2O, which is wrong since NaBH4 does not reduce carboxylic acids. Option D shows a methyl ester, CO2CH3, which is not formed under these conditions. Therefore, the correct answer is A. Therefore, the correct answer is option A.